Hey there everybody, welcome to our lesson today on the surface area of a pyramid. Okay, as you can see here on the opening slide, we have a picture of a pyramid. So let's talk about all the different parts of a pyramid. First of all, what kind of a pyramid is this? You can see the base has 5 sides, so this will be called a pentagonal pyramid. Okay, just like a prism, we can have pretty much any shape that we want to as a base. A triangle, a rectangle, a pentagon, hexagon, octagon, decagon, anything for our base. Okay, but if you look at the sides, the lateral sides, those are always going to be triangles in a pentagon. Okay, so let's go through each piece of a pentagon, of a pyramid that you should know. Starting from the top, that point right there at the top, that's called our vertex. This red dashed line right here that goes from the vertex to the middle of the pentagon, well, that's our height, or another word for that would be altitude. This yellow dashed line that goes from the vertex to the middle of one of our sides, that's called our slant height. And remember, we still use the cursive L for that. Okay, the next one here, this line is pointing to this. So from the vertex to one of the points on the base, okay? Or this one, or this one, or this one, or the one in the back. Okay, that's called a lateral edge. And it's important for you to know the difference between the slant height and the lateral edge. Okay? The lateral edge really does nothing for our formula here. The slant height is very important, as you'll see when we get to the next slide. Next box down here is pointing towards this face, okay, towards this blue face over here. Okay, since it's not the base, that's just one of our lateral faces. And we already talked about this, but for pyramids, these are always going to be triangles for pyramids that we're working on here. The next one here is pointing towards this red dashed line. This is a word from our past that we've used a lot in chapter 9 with area. This is our apothem. And finally, the last one is pointing towards the pentagon. So the pentagon is our base. Okay, and for pyramids, there's always only one of those bases. Whatever shape it is, there's only one base. All right. So as we go through the notes today, at any point here, if you need a little bit more time, feel free to pause the video. If you feel like you missed something, feel free to rewind the video. You can go back and you can rewatch whatever you missed as many times as you need. All right, let's start with our formulas. The lateral area is made up of triangles, as we just discussed above. So to find the lateral area, what you're going to do is you're going to find the base of one of the triangles. Okay? And we're going to multiply that base by the number of triangles, or the number of sides in the base. All right, and that's going to get you your perimeter. All right, so think about how do we find the area of a triangle? We do base times height over 2, right? But since we're doing the perimeter of all the triangles added up together there, of all these sides, the bases of all the triangles is the perimeter. Our formula is going to be PL over 2. All right, so P acts as our base of the triangles, L is our slant height, so the height of the triangles, and over 2. So base times height over 2. Okay? Skipping down here, P, what does P stand for? P stands for the perimeter of the base. Again, whatever shape that base might be, triangle, rectangle, pentagon, whatever. L still stands for our slant height, just like for when we did cones. All right, the next line here. So to then find the total surface area, we simply have to add in the area of one base because there's only one base, whatever shape that base is. So we take our lateral, and then we add in B, where B is the area of the base. That's it. So now we're just going to try a couple problems. Again, if you need any help, you can rewind the video, play it again as many times as you need. And at the end of the problem, if you need to spend a little bit more time on it, feel free to pause the video and take as much time as you need. So question was, says to find the lateral area and surface area of an equilateral triangular pyramid with base, side length 11, and slant height 14. So that means these are all 11, right? And then it says that the slant height, which is somewhere around there, is 14. Okay, so let's start with our lateral area. And our formula from up above is PL over 2. So perimeter of the base times the slant height divided by 2. Well, the perimeter of the base is just 11 plus 11 plus 11, or 3 times 11, which is 33. Our slant height is given to us. It's 14. So all we got to do is type in that into our calculator, and our lateral area is 231 square meters. So to find a total, we're just going to do 231 plus the area of the base. So now you got to think, all right, what shape is the area of the base? It's an equilateral triangle. So you still can use your Chapter 9 formula sheets with all the area formulas on it. The area of an equilateral triangle, remember, is side squared root 3 over 4. So this would be 11 squared root 3 over 4. Again, we can go to our calculator and type that in, and we get that the area of the base is 52.39. So now we can add that back into our formula. Add those two together, and we get our total surface area is 283.39 square meters. All right, question 2 says find the lateral area and surface area of the square pyramid with base edge length 9. So these are all 9 here. And slant height 17. So once again, we'll start with our lateral area, which is PL over 2. The perimeter of the base. The perimeter of the base is just 9 plus 9 plus 9 plus 9, or 4 times 9, which is 36. So that'd be 36 times the slant height 17 over 2. And if we type that into our calculators, we should get that our lateral area is 306 square centimeters. So to get our total then, we're just going to do 306 plus the area of the base. Okay, so what's the area of the base here? Well, it's just a square, so we're just going to do side squared. The area of the base is 81. So our total is 306 plus 81, which is 387 square centimeters. Number 3 says find the lateral area and surface area of the regular hexagonal pyramid. All right, this is where things can get a little bit difficult. So the first thing we're going to do is find our lateral area, just like before. So lateral area equals PL over 2. So the perimeter of this, one side is 12. There's 6 sides, so our perimeter is 6 times 12. Or 72. So our perimeter is 72. But we don't have the slant height. That's the problem. What we're given here is not the slant height. We are given a lateral edge. But we can use that lateral edge to get the slant height by drawing in a right triangle like that. And remember, this whole side is 12, which means when we draw the slant height in, this piece here is 6. And we don't know L, but hopefully by now you know how to find L. 6 squared plus L squared equals 10 squared. Good old Pythagorean theorem helps us every time we're missing a side of a right triangle. And we should get that our slant height is 8. So plugging that back into our lateral area formula, we can find that our lateral area is 72 times 8 over 2, or 288. So our lateral area is 288 square feet. All right, then for our total, it's just 288 plus the area of the base. But the area of the base is not as easy as our first two problems. Okay, it's a hexagon. I know this is 12. So remember, we want to find our hexagon here. What we want to do is we want to find the area of one of these triangles and go from there. So we know these are both 6. We don't know this. 360 over 6. Each central angle is 60. And if we cut that in half, these two little pieces here are 30. So this is a special right triangle, or we can use right triangle trigonometry to get our apothem there. So let's use tangent of 30 equals 6 over x. So x tangent 30 equals 6, or x equals 6 over tangent 30. So 6 over tangent 30 in your calculator. Our apothem here should be approximately 10.392. So now we can do the area of that triangle. So that area of that triangle then would be base times height over 2. And that would give us 62.354. Then you want to ask yourself, well, how many of those triangles make up that hexagon? And the answer to that is 6. So to get our total area of the base, we're going to do 6 times 62.354. And the area of our base is 374.123. So then finally, 288 plus 374.123, our total surface area is 662.12 square feet. Number 4 is going to be a little bit easier than that because this time the slant height is given to us. So we know that a base edge is 2 and a slant height is 4. So our lateral here is going to be real easy because we have everything we need. The perimeter of the base, there's 5 sides of length 2, so 5 times 2. The perimeter is 10. The slant height is 4 over 2. Our lateral area is 20. So lateral equals 20 square centimeters. So our total then is just going to be 20 plus B. So the tricky part here again is finding B, finding the area of the base. So here we have a pentagon. That's not a pentagon. That's a pentagon. All right. So we have a pentagon, side length 2. So if we draw in our triangle here, these are both 1, and we're looking for this. So once again, we can do 360 over 5 because there's 5 central angles, and that's 72. And then cut that in half, we get 36. So both of these angles up here are 36. So to get x, we can do tangent 36 equals opposite over adjacent. And then same as before, x equals 1 over tangent 36. Okay, so if we put that into our calculators, we should get x is approximately 1.376. That's our apothem. So then the area of that triangle is base times height over 2, which happens to just also be 1.376. So then ask yourself, how many of those triangles are there? There's 5 of them. So our base is going to be 5 times that, which is 6.882. So back over here, our total area is 20 plus 6.882, which is 26.882 square centimeters. All right, last one. This is the lateral area of a regular pentagonal pyramid is 150, and the length of each side of the base is 6. Find the slant height. So the key here is that we're talking about lateral area of a pyramid. So we're going to go ahead and write down our lateral area of a pyramid formula, which is PL over 2. So what do we know? We know that L is equal to 150. We're told that. And we're also told that each side of the base is 6. Okay, well, side is not in our formula here, but we know a pentagon has 5 sides, right? That's a terrible pentagon. That's a hexagon. One more try here. There we go. Each side is 6. There's 5 sides. So that means that the perimeter of that must be 5 times 6, or 30. So I can put 30 in for P. I don't know the slant height, over 2. And then we got to solve that for L. So 30 over 2 is 15. Divide both sides by 15, and we get L equals 10. Now remember, for units, this is not an area. It's this linear measurement. So it's just centimeters. All right, that is it for notes for today for the surface area of pyramids. If you need to, you can go back and rewatch anything that you need, anything that you missed. Next class, we will be doing some practice problems on these shapes.